Welcome to this 11 Plus Maths Masterclass. Today we are going through HCF, highest common factor. This comes up time and time again, so we need to know how to work it out. Now the good news is, working out HCF and HCF related questions is easy marks if you know what you're doing. So if you watch this video all the way through to the very end, you will never get this question wrong ever again. So if that sounds good, let's go straight into this teaching. Now, when we're working out HCF, we can't just rush straight into it. Working out HCF is a process, and we need certain building blocks of understanding before we can actually approach HCF questions in full. So the first concept we have to understand, and we're going to go through, is that of factors. Okay, so let's start at the very beginning. What are factors? And we're going to use this number here, 8, to explain this. Now, a factor is simply any number that divides evenly into our given number. And by evenly, we mean leaving no remainders. So if 8 is our given number, then we could say that 1 is a factor of 8. And that's because 8 can be divided by 1 without leaving a remainder. Why? Because 8 divided by 1 gives us 8. So 1 is a factor of 8. Same thing with 2. 2 is a factor of 8 because 8 can be divided by 2 evenly without leaving a remainder. When we do that, we're left with 4. So you can see that 5 wouldn't work. 5 is not a factor of 8 because it does not divide evenly into 8. When we divide 8 by 5, we have 1, remainder 3. So that's what a factor is, any number that divides evenly into our given number. So we have 1, we have 2, but then we also have 4 and 8. So the best way to think about factors, non-technically, is really just any number that goes into our given number. So 1 goes into 8, so does 2, 4, 8. These all go into 8, so therefore they're factors of 8. So now we understand factors, but really when it comes to our 11 plus maths exam, we need to be accurate, but we also need to be quick. So therefore the best way to think about factors is simply by using factor pairs. And factor pairs help us to find factors extremely quickly. And what we do is we simply find pairs of numbers that we can multiply together to give our given number. So for example, if we look for factor pairs and our number is 8, we can think of 1 and 8. Why? Because 1 can be multiplied by 8, or 1 and 8 multiplied together to give us 8. And then we can think of 2 and 4. Why? Because again, 2 times 4, using our times tables, gives us 8. Now it's way more effective and efficient to think of factors in this way. So let's try 12. And let's use our factor pairs. What numbers can we multiply together to give us our given number, 12? What are the factors of 12 using factor pairs? Well, we can always start with 1 and that number, so 1 and 12. 1 times 12, 12 times 1 is 12. But then we also have 2 and 6. But then we also have 3 and 4. So can you see, by leveraging or by using our times tables and using factor pairs, we can find the factors very easily. And let's take one more example. This is really important we properly understand this for HCF. 36. What are the factors of 36? What numbers go into 36 using factor pairs? Well, again, always start with 1 and that number. It's the easiest win. So 1 and 36. But then we also have 2 and 18, 2 times 18. We also have 3 and 12. We also have 4 and 9. 4 times 9 is 36. And finally, we have 6, because 6 times 6, 6 squared, is 36. So can you see that it's really important that we have strong times tables? So that's how factors work. Any number that goes into our given number. Next, to work out HCF, we need to understand prime numbers. Now, when it comes to prime numbers, we simply need to remember the definition. A prime number is any number that has only two factors. So you can see our understanding of factors is going to help us out here. And those two factors are itself and 1. So any number that only has two factors, itself and 1, can be classified as a prime number. So let's try something. Using that definition, I'm going to write out the first 5 prime numbers, but I'm going to make a mistake. Can you spot the mistake? So, first 5 prime numbers. Let's say 1, 2, 3, 5, and 7. Are these the first 5 prime numbers based on our definition? Now the answer is no. The mistake here is 1. 1 is not a prime number. To understand this, we have to go back to our definition. Remember, prime numbers have two factors, itself and 1. But with 1, we only have one factor because itself and 1 are the same thing. So make sure we don't get caught out in the exam by wrongly classifying 1 as a prime number. 1 is not a prime number. So really, the first 5 prime numbers are 2, 3, 5, 7, and 11. These are our first 5 prime numbers. Awesome. Now that we understand factors, we understand prime numbers, we can now move on to working out the highest common factor. Now, to work out HCF correctly, every single time, we have to follow 3 steps. The first step is we need to work out the factor trees or draw the factor trees. Factor trees are simply diagrams we draw that show us the factors of different numbers. So for example, if we go back to 12, let's draw the factor tree for 12. We think about the factors of 12. And really important before we do that, the rule when it comes to factor trees is we always stop when we reach prime numbers. So let's write that down. So now we can draw our factor tree for 12. So we think to ourselves, what are the factors of 12? Again, we can use our factor pairs. 12 can be broken down into 3 and 4. 3 times 4 gives us 12. We're going to stop at 3. We're not going to go any further because 3 is one of our prime numbers. So therefore, there's no point. We're not going to go into 3 and 1. We always stop before we reach 1s. So we stop at 3. So 3 and 4. But we can break down 4 further. 4 is 2 times 2. So we can break 4 down into 2 and 2. And again, we stop there. We don't go into 2 and 1. So here we have our factor tree for 12. 3 and 4, and then 4 into 2 and 2. We draw our factor trees for every single number. Now, after we've drawn our factor trees, our second step is to identify our prime common factors. And don't let this scare you. We can break it down step by step. Prime common factors. Prime meaning a prime number. We know what prime numbers are. Common factors simply meaning these are factors that are shared across both factor trees. So prime number shared across both factor trees. So quickly, let's draw the factor tree for 20. 20 can be 10 and 2. We stop at 2, we can break down 10 further. 10 can be 5 and 2. So now we have 2 factor trees, and we can identify our prime common factors. So we have prime numbers 3, 2, 2, and 5, 2, 2. But we don't just want prime numbers, we want prime common factors. They need to be shared across both factor trees. So our shared prime numbers are 2. We have another 2 over here. And that seems to be it. So we have 2 2s that are shared across both factor trees. So now we've done our second step of identifying our prime common factors. So finally, our last step is to find the product of those prime common factors. And again, don't let product scare you. Product is just a fancy word for multiply. So if we're finding the product of 2 numbers, we're finding the result when we multiply those 2 numbers together. So here we have 2 and 2, so we do 2 times 2. We multiply 2 and 2 together, giving us 4. And just like that, we've worked out the HCF of 12 and 20. It's going to be 4. So now we know how to work out HCF. Let's try it on some exam style questions. So here we have what is the highest common factor of 20 and 36. Whenever we see this, just go straight back to your rules, go to your steps. Step 1, factor trees. Step 2, prime common factors. Step 3, product, multiply. So let's start with step 1. What are the factor trees of 20 and 36? Let's draw them out. So 20, we can break this down into 10 and 2. Or we can break it down into 5 and 4. A quick note is, no matter how you break down these numbers, if you do it correctly, you will reach the same answer. And we can prove it. So let's start by doing 10 and 2. And then 10, we'll do 5 and 2. Remember our rule, we stop at prime numbers. And we don't involve ones. Next, we have 36. 36 can be 4 and 9. 4 we can break down into 2 and 2. 9 we can break down into 3 and 3. So factor tree step completed. Now we have prime common factors. Which prime numbers are shared across both factor trees? Well, I'm seeing a set of 2s and another set of 2s. So we have 2 2s. So 2 times 2 equals 4. So we've done our prime common factor step and we've done our product, our multiplying step, and our HCF equals 4. But quickly, let's prove if we get the same number, or that we get the same number, if we break down the trees differently. So now we have 20 and 36 again. This time, let's break 20 down into 5 and 4. 4 can be broken down into 2 and 2. We stop there. 36. This time, let's do 12 and 3. 12 can be 6 and 2. And 6 can be 3 and 2. Now, factor tree step done. Prime common factors. What are our prime shared factors? Well, I'm seeing some 2s. And I see another pair of 2s. Can you see it now? Can you see how we're coming to the exact same answer? Because when we do our third step, which is the product of those prime common factors, what do we get? 2 times 2, giving us 4. So no matter how you split up or break down the numbers using factor trees, if you do it correctly, using your factor pairs and times tables, you will come to the same highest common factor, which in this case is 4. Let's try one more example. So now we have what is the largest number that goes exactly into 90, 210, and 300. So it's another way to say work out the highest common factor, HCF, of these 3 numbers. So the exact same steps are what we are going to take. We start by drawing the factor trees. It does not matter how big these numbers are. So 90, 210, 300. 90 can be broken down into 10 and 9. 10, 5 and 2. 9, 3 and 3. Remember, we always stop at prime numbers, so we're done with that one. 210. Well, this can be broken down into 70 and 3. 7 times 3 is 21, so 70 times 3 should be 210. So 70 and 3. We stop at 3, but 70 can be broken down into 7 and 10. 10 into 5 and 2. Always stop at the prime numbers. 300 can be 60 and 5. 60 can be 12 times 5. And 12 can be 6 and 2. 6 can be 3 and 2. So can you see how important it is to understand factors? We're using them now when working out HCF. Step 1 complete. Step 2, what's step 2? Prime common factors. So now let's work out or identify the prime numbers that are shared across all 3 factor trees. So I'm seeing some 3s. What else can you see? I can see some 2s. And I'm also seeing some 5s. That seems to be it. So we have 2, 3, and 5. These are our prime common factors. Check. Step complete. Final step, the easy part. Product of the prime common factors. Simple terms, multiply them together. What do we get? We have 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is 30. So our HCF is 30. And there you go. That is how you work out HCF correctly every single time. And you see, it's not that hard. All we need to do is understand factors, understand prime numbers, and then use our steps. Factor trees, prime common factors, and then find the product of those prime common factors. So now try this for yourself. Get some HCF questions, get some random numbers, work out the highest common factor, and see how these steps work for you. So that's the end of this 11 Plus Maths Masterclass. Remember to use these steps to make sure that you never get an HCF question wrong ever again.